Hello friends, welcome to my channel Vaji's Revision and Notes. Today we'll continue with the next unit, that is computer networks. Before that, last class we saw TOC questions from UGC NET August paper. So one question was left. So we'll see that question. That is a TOC question. UGC question only, and arrange the following language classes in ascending order according to their expressive power as defined by the Chomsky hierarchy. So, you know that their options are given. C starting is C. C is what? C is regular language. A is context-free language. So context-free language comes in between. So cannot be the option. So 1 or 2 is the option. So C, first option C. Then A, B, and D. So C is your regular language, A is context free language, B is context sensitive language, and D is unrestricted grammar. So the correct option is 1, that is the option 1. C, A, B, and D. This is question number 63. Consider the three-way handshaking process followed during TCP connection establishment between two hosts A and B. Let S and R be two random 32-bit starting sequence numbers chosen by A and B respectively. Suppose A sends a TCP segment having sync bit equal to 1, sequence number equal to S, and acknowledgement bit equal to 0, and B accepts the connection request. Which of the following choices represent the information present in the TCP segment header that is sent by B to A? So they're asking from the B to A. So a sync bit is set to 1 when a host A initiates a TCP connection. Then sequence number. What is sequence number? It is a unique identifier chosen for each byte of data. Acknowledgement bit is set to 1 if the segment has a valid acknowledgement. Then acknowledgement number. What is acknowledgement number? It is the byte number that the receiver expects to receive next. And finish bit is set to 1 to indicate the end of the data transmission. So these are the notes for the various terms in this question. Okay, so now from B, when B sends a message to A, then the sync bit will be what? The sync bit will be 1, the same as the A. Then sequence number will be equal to R because it is sending from R. The sequence number starting from B is R. And then what will be the acknowledgement bit? Acknowledgement bit is set to 1 when it has a non-valid acknowledgement. So it is set to 1. Acknowledgement bit is 1. See, the acknowledgement bit will be 1. And then what is the acknowledgement number? So acknowledgement number will be the next byte that is the receiver expects to receive. So already S is so sequence number, next the acknowledgement number will be S plus 1. So acknowledgement number is S plus 1. And finish bit is 0. If it is 1, only if it is end of the data transmission. So now it is not end, so fin bit will be 1. So this is option number 3. Option number 3, sync bit equal to 1, sequence number equal to R, acknowledgement bit equal to 1, and acknowledgement number equal to S plus 1, fin bit equal to 0. Two computers A and B are configured as follows. A has an IP address and a subnet mask of subnet mask is given, and B has an IP address and a subnet mask. So which of the following statement is true? So let us see how to solve this problem. Here the network ID specifies the specific network in which a device is, and then host ID specifies the individual device within the network. So when all devices are on the same physical network means they will have the same network ID. Then what is subnet mask? Subnet mask means it defines which portion of the network, which portion of the IP is the network and which portion is the the host. So that's why we use subnet mask. Say for the given problem for computer A, the given A's IP address is this much, and then the A's subnet mask is this much. Okay, so when you know that, we can find out the network ID of A. How will find the network ID? Network ID is found by AND of the IP address and the subnet mask. So we do the AND of this both, that is 103.197.2.53, then 255.255.128.0. When you do the AND, the first digits remain as such because they are the bottom has to all one, so we get only 203.197. And then this is the value for 2.53, and then below is the value for 128.0. When you do the AND, you find that you will get 0.0. All are zeros only. Similarly, you find the network ID of B. So how will you calculate? You have the B's IP address and this subnet mask of A, because now we are going to do in based on the computer A. So you take the subnet mask of A. So 255.255.128.0. If you do the AND, you'll get the network ID as seen by B. So when you do the AND, you will get value as, see, 75. This value 201. You take the binary digits. For 128, 1 followed by zeros, and then for 0, all zeros. So when you do the AND, you will get 0.0 only. See, this is 0. Here also you'll get 1 and 0. You'll get AND is 0. So the network ID of B is also 203.107.0.0. So here you see that for computer A, the network ID of A and B are same. Hence, A assumes that B is on the same network. Now we take computer B. So B's IP address is given and B subnet mask is this one, it's given. So when you do and find the network ID of B for the computer B, so you AND the subnet mask and IP address. Here you take the subnet mask of B only. So here we do the AND, we'll get the values. See, for 75 it is this value 201, this value, write the binary digit, and again for the IP means subnet, it is 255.255.192.0, which is this value. So when you AND, you will get 64.0. You get one value 1, okay, 1 and 1, you get AND 1. So the value is 64.1. So this is the network ID of B. Now here similarly, if you find out the network ID of A, so A has IP address this one, and the subnet mask, that is the B subnet mask, if you take, then you AND both. So here similarly you AND both, you find you will get the value as 203.197.0.0. So you don't get the same network ID as B. So B's network ID is 64.0, but here the network ID of A is 0.0. So as both are differing, so B tells that the network ID of B is different from A. Hence A will assume that, so A assumes that what? It assumes that A is on a different network. Hence you find that the option number 3, that is A assumes that B is on the same network. So according to A, B is on the same network. But according to B, B assumes what? A is on a different network. Okay, based on the results. Okay, so this is the correct answer. This is the correct option. Question number 65. A class B network on the internet has a subnet mask of 255.255.2448.0. What is the maximum of hosts per subnet? Here the subnet mask is 255.255.248.0. So write it in the decimal form. We'll get these ones. Here you know that the subnet mask means the ones are all network IDs and then the zeros are all host IDs. Here you know it is a class B, is given as class B network. So in class B you have first 2 octets will be network, next 2 will be it will be host, so host bits. But here they have taken some bits from the host as for subnets. So 1 2 3 4 5, so 5 bits are 1, so these are taken up as for subnets. Hence we find that number of the bits for hosts is, that is the last octet, that is 8 plus this 3. So these are the host bits. So totally how many bits for the host? There are 11 bits for the host. So you will have 2 power 11 addresses. So get 2 power 11 addresses for the host. So put 2 power 11 means it is 2048 addresses. You get 2048 addresses. You have to subtract 2 because 2 addresses are reserved for network ID and host ID. So 2048 minus 2, that is 2046. Hence the answer is 2046. Option is the third one, that is 2046. Next question number 66, that is in a token ring the transmission speed is 10 power 7 bits per second and propagation speed is 200 meters per microsecond. The 1 bit delay in the network is equivalent to, here you find that the propagation speed is 200 meters per microsecond. So 1 microsecond means 10 power minus 6 seconds. So 10 power minus 6 seconds distance covered is 200 meters. So in 1 second distance covered is 200 by 10 power minus 6, which is 200 into 10 power 6 meters. So what is the transmission speed? The formula is data length by bandwidth. So the data length is 200 into 10 power 6 meters and the bandwidth is, transmission speed is 10 power 7. So 10 power 7 bits per second. So you divide these 200 10 power 6 by 10 power 7. You will get the value as 2 into 10 power 1, that is 20 meters. So option number 1 is the correct answer. Next, consider a CSMA CD network that transmits data at the rate of 100 Mbps over a 1 kilometer cable with no repeater. If the minimum frame size required for this network is 12550 bytes, what is the signal speed in kilometer per second in the cable? So for this question, the minimum frame size given as 1250 bytes. So convert to bits, you will get 10,000 bits. So bandwidth is given as 100 Mbps. So 100 into 10 power 6 bps, that is bits per second, which is 10 power 8 bps. Now transmission time, t is equal to frame size by bandwidth. So here you have 10,000 bits by 10 power 8 bits per second. You get 10 power minus 4 seconds. Propagation time is distance by speed. Here distance is 1 kilometer and speed is, you have to find out what is the speed. So here in for CSMA CD, the condition will be, you have to satisfy this condition, that is transmission time will be greater than equal to twice the propagation time, so that when you transmit, you'll get the detect the collision. So it has to be transmitting. So the transmission will be greater than equal to 2 into propagation time. So 10 power minus 4 will be greater than equal to 2 into this propagation time is 1 by v, velocity. So here you can substitute the values and find out the value of v. So we will be 2 into 1 kilometer by 10 power minus 4 seconds, which is 2 into 10 power 4 kilometer per second, which is 20,000 kilometer per second. Hence the answer to this problem is 20,000. Okay friends, we have covered 5 problems from computer networks. You should see the remaining 5 problems in the next video. I hope this was useful to you. Please do like, share and subscribe my channel. And please write comment section. Thank you.